The fundamental is the whole string. From this point to this point, the whole string is vibrating. And that's one string. That one string is 34 inches long. If you take half of 34, my thought process is half of 30 is 15, half of 4 is 2, so 15 plus 2 is 17. All right, 17 inches, there's the halfway point. I'm gonna just mark it here with some tape. Now the fundamental by itself, if we stop it from vibrating and just hold it there, only this part will vibrate, this half. This half is also vibrating, so it's like we've multiplied it by 2.
And what musical interval is multiplying by 2?
Well, that's, it's called an octave, yes? Would you agree?
Yes, and I would say to my ear, I've been trained to recognize the octave as the same note.
Yeah, sure, G.
G.
And then we call this a G as well.
Right. 1 octave higher.
Great point. So in a way, we're multiplying it by 2. There's a 2 to 1 ratio. 1, this fundamental 1, and then 2. So we're hearing this vibration. We're stopping it here, and we're hearing it here too. Because if I hold it here, it deadens the note. Something else that's interesting, we have frets at certain places. I can push it down, essentially making a string now that's half the length, and it's going to play that same note, that same octave. So we've cut it in half. What's 1/3 of 34?
Well, that would be 11 1/3.
Perfect. 11 and about 1/3, right about there, and just it should do something like that. So there's a 1/3 there, there's a 1/3 here as well. So we're gonna get green.
Right, depending whether you take 1/3 from the bridge or from the nut.
Right, so 11 and a, wait, what was it? 11 and 1/3?
Yeah.
Right there. So right about there. So now you can see 1/3, 3/3, there you go. 1, 2, 3. And again, you can isolate a 1/3 by stopping the vibration just by touching the string.
Is it the same if you do the other 1/3?
If you touch it here, yeah. So it's interesting, the wave.
Now,
What's happening there? I need your help. Can you touch there? Okay. And I'm going to touch here. I don't know what will happen. So yeah, if you could touch here, you could touch one place, it's being isolated. So we're only getting vibration in the 1/3s. And this is like a quiet spot. Whether if I quiet it here, this will also be quiet, even if I touch it or not.
right.
Interesting.
Now, with the white piece of tape, you could stop it at the fret and you would get the same note.
Yep.
Does that work with the green tape?
It's a good question. So there's that way of isolating it. Let's press it down. So now this is literally just 1/3 of the length.
All right, it worked.
Yep.
How about the other green piece of tape?
So how are we going to do that? Here's 1/3. We're measuring 1/3. And we're not going to hear this.
Well, but I just want you to press this fret and then play the note here.
Okay, so
What's going to happen then?
okay, we're going to have 2/3 then. Well, gosh, that is the same note, but I can hear it. It's 1 octave below this one.
Right. But you were going to suggest a different experiment where we stop the note here and we play it there.
So I'll do that, but because the pickups are over here, there are no pickups here to pick up the sound electromagnetically. You won't hear anything. Yeah. maybe the microphone can...
Okay, that sounds to me like a bad version of the same note.
Yeah, but it is close. I think
Yep.
it's because of the frets and how they're laid out. That's another story. But
Great. Well, that's a third. What would be the next integer ratio?
4, right? We're going 1, 2, 3, 4.
Okay, so what's
34 divided by 4?
Well, that would be 17 divided by 2.
That's the same, yeah.
So it'd be like 8.5.
Cool.
Isn't that funny? You've got a fret there.
Pretty close. Let's see, 8.5. Oh, it's like right on the fret. Wow. So right here, let's go with red. Right there. You know.
So what if we did 8.5 from this side?
Right about there. Okay. And then there's going to be another, right? Because we're doing quarters. Quarter.
Yeah.
Oh.
It lands on the white one.
It lands on the white one. All right.
So 2 quarters is 1/2. That's what we're saying with the tape.
Yep. 1, 2, 3, 4. So if we press here, stop it from vibrating and isolate these vibrations. You do that here too.
So now I have a trick question for you.
All right.
Why don't we hear the 2 octave up note when we stop it at the 2 quarters point? It's a trick question because you do hear
the
quarter note.
But it's quiet. This overwhelms it.
Right. So we could do an experiment now where one of us stops here and the other stops there, and then you pluck the note and we'll skip just the quarter again.
Yep. Yep.
So you're right in some sense that when we stop it at a quarter, this point stops too. But if we stop it at a half, then this point does not necessarily stop.
Yeah.
And you get that lower. So the quarter is actually 2 octaves.
Mm-hmm.
It's 2 times 2.
Yeah, we can hear it.
And we perceive it also as a G, the same note.
Yeah, so we're going to show that right now. G, a low G, 1 octave up from there, and then another octave from there.
And what note was the green third?
That's definitely not the same note as if you just sing.
So what note is the G? The third of.
In a musical scale, it's related to the 5th because we're talking about, let's say, do, re, mi, fa, so. Oh, that's a D.
Okay.
The fundamental, the half, third, and fourths. Fifths is next.
So 34.
34 divided by 5.
5.
That's a little trickier, isn't it?
Well, 30 divided by 5 is 6.
Mm-hmm.
And then 4/5 of an inch.
Great. 6 and 4/5.
Okay.
All right.
It's pretty close to one of your frets.
Pretty close. I have to be accurate to hear it. Let's use blue. Do you hear the note?
It's getting very high for a bass guitar.
Yeah. Let's get one down here too. 6 and 5/5, right about there. That's 5, so we're going to have one over here too. My goodness. At least one more, because we're dividing this into 5. 6 and 4/5. And down here.
And in this case, we don't have any pieces of tape that have landed on another piece of tape for the blue tape. So we shouldn't expect to have the same weirdness we had with the 4.
Right, because it's an odd number. It's not even where you could fold it in on itself.
Uh-huh. It's a prime number.
5 is a prime number. So anywhere we touch, going to have the same effect. Where it quiets these nodes, would that be a good word to use?
Absolutely.
So there's a node, and a node, and another node.
So a node is a place where there's no movement.
In the musical scale, what would that interval be? If you think back to do, re, and solfege.
That's me. That's the third.
Yeah. You can hear it here.
A little bit too high for me to sing perhaps by now, but...
Well, we'll go down now.
Do, re, mi.
Yep. Oh, the red is do too. Because we got this do, this do.
Those are quite pleasing notes together.
My goodness, yeah.
I would call that a major chord.
It's a major triad. You got it. So it's in a different octave. It's not as simple as do. Wait. Do, do, mi, so, mi, do. That's if you were to take those and line them up simply from do, mi, so.
In the same octave, they would become
There you go. Yes.
a major triad.
Yeah.
Most of our pieces of tape have landed on a fret.
Or close. And actually, you'll notice not exactly.
So, yeah, why is the third not exactly on a fret? Just let's try it. If you put your finger on that fret for me and you pluck the note, do we get the same harmonic?
I can hear how it's a little different. So what we do conventionally with frets is we lay them out evenly. Just divide it and chop it up into pieces so that you have...
Even musical intervals, not even differences.
Exactly. Yeah. Why are these frets wider, further apart, and these frets are closer together? As you get higher up, so you have a lower note. As you get higher, the frets come closer together on a fretted instrument.
Well, John, I'm going to say they are equal if you use a logarithmic scale. So if you had a bass guitar that had 24 frets, that 24th fret would be here.
Or maybe it would be here at the octave.
Oh, sorry. Yes, at the octave. Thank you.
Mm-hmm.
And so if you counted 12 frets from here to there, you'll see 12 frets in the distance that you have 12 frets in the first half of the guitar. And if you managed to build a guitar that had 36 frets, they would be a quarter of the way. And so if you wanted to build a guitar with all the frets, you would need an infinite number. And they would all be over here.
Uh-huh.
That is to say, the way that we hear pitch, which is actually, I think, related to these strips of tape that you've placed on integer ratios, is such that an even distance to our ear is in fact a logarithmic distance along the fretboard. So when you cut something in half, you could think about it as multiplying by 1/2. And if you want to make 12 steps to go up an octave, you would multiply by 2 to the 1/12 power. So 2 to the 1/12 power gets you here, 2 to the 2/12 power gets you there, 3/12, and so on until you get to 2 to the 12/12, which is 2 to the 1, which is 2. So this very strange mathematical object, 2 to the 1/12, is the basis of the equally tempered scale.
Right.
And what that means is that every single interval has been adjusted from its perfect tape location, or every single fret has been placed equally without regard to how close it lands to a piece of tape.
A node.
A node. However, in the case of the 12th fret, it lands exactly right. And if we turn the math, we'd find that these green ones that are a third of the way, they come almost exactly.
Yeah.
Very close. However, when we get to other intervals, especially this blue one, the third, it's actually pretty far out.
And you can even see by the tape where it's placed. It's behind the fret.
There's a sound wave going through your string from one end to the other. And it's going at a constant speed. And so it has longer to go from one end to another if you don't stop the note. But if you stop the note in the middle, then it has less distance to travel, so it will get there faster and you'll hear a higher note. 34 divided by 6.
Okay.
Well, 30 divided by 6 is 5. So you have 5 2/3.
Right about here. That sounds familiar. Like it's... What was it again? 6? Didn't we do 3 already? I think it's going to be related to the one that's a third.
So if you stop it at one of the green ones now. Oh,
right. It's an
so
octave.
That's an octave
an octave
and a
higher.
fifth. It's a D that's an octave higher.
Yeah. That makes sense. All right.
Very good.